Good day everyone and welcome to Physics Department. You are now in Lesson 2 which is Kinematics. Kinematics is mostly related to the word kinetic, so obviously we will talk more on the motion. But before anything else, I would like to introduce myself first. I am Leslie Hermahino and I will be your instructor for Lesson 2 and 4. So if you have questions after this video, you may contact me on my Facebook. So yeah, that's all for introduction. Let us go now with the discussion proper. In lecture 2.1, we will talk about the speed, velocity, and acceleration, which I bet you are familiar with. Speed, as stated, is a scalar quantity representing the total distance traveled per time. So I want to emphasize here the scalar quantity. We have two quantities, scalar and vector. Scalar quantity means it has magnitude but no direction. Vector quantity has a magnitude and direction. You should be mindful of these quantities. So in order to solve for speed, we need to divide the distance over time. As simple as that. S is equal to d over t, where S is speed, which has a unit of meter per second, d for distance, which has a unit of m, t for time, which has a unit of second. Next, velocity. A velocity is a vector quantity representing the total displacement traveled per unit time. So, velocity is a vector quantity while speed is a scalar quantity. So, the formula for velocity is x minus x sub 0 over t, where v is the velocity, which has a unit of meter per second, t is for time, x the final position, which has a unit of m, and x sub 0 is the initial position. Next, the acceleration. Acceleration is the change in velocity per unit time. The formula for acceleration is v minus v sub 0 over t, where a is acceleration, which has a unit of meter per second, t for time, which has a unit of s, v for final velocity, meter per second, v sub 0 is the initial velocity. Uniform acceleration motion, or UAM, is the simplest kind of motion in a straight line, which the speed changes at a constant rate. So we have here four formulas. First, the x minus x sub 0 is equal to quantity v plus v sub 0 multiplied by t over 2. The second one is x minus x sub 0 is equal to v sub 0 t plus 1 half at squared. Next is the v is equal to v sub 0 plus at. Next is v squared minus v sub 0 squared is equal to 2a multiplied by the difference of x and x sub 0, where x the final displacement, x sub 0 is the initial displacement, v is the final velocity, v sub 0 is the initial velocity, t is time, and a is the acceleration. So, we can use these four formulas, pero hindi lahat. Usually, in solving uniform acceleration motion problem, we only use 1 to 2 formulas. So, what I want to say here is that the formula that you will use will depend to the given you have and to the unknown. For example, we have this given initial velocity, acceleration, and time. And we are looking for the final velocity. So we will use this formula. V is equal to v sub 0 plus at. Got it? So next, let us go in gravity and free-falling bodies. As stated, inertia is the resistance to change in motion in a property or body. Kung baga, lumalaban siya sa change. That's what we call inertia. And since we are talking about falling bodies, gravity is included. So we have here gravitational acceleration is a UAM used for treating falling bodies. So, you know that gravitational acceleration is equal to 9.8 meter per second squared or 9.81 meter per second squared. But I would highly recommend that you use 9.81 meter per second in your quizzes or exam for more accurate answers. Okay, so if you will convert meter per second squared by feet per second squared, that will be 32 feet per second squared. So this will be our formula for gravity and free falling bodies. This somehow look like the formulas on UAM or in uniform acceleration motion, but since it is a falling concept, we will use y instead of x, and we will use g instead of a. Just imagine the Cartesian plane. X is for horizontal motion, y is for falling motion. So our formulas are also for where y is final height, y sub 0 is initial height, v is for final velocity, v sub 0 is initial velocity, t is time, and g is acceleration due to gravity, which is equal to 9.8 meter per second squared or 9.81. So, gaya kanina, depending on the given you have and to the unknown, the formula you will use. Okay? Next, sign conventions. When solving, positive and negative signs are vital. I hope you are aware of that. Even though you know the solution but you use the wrong sign, it will still lead you to wrong answers. So acceleration and velocity will be positive if the resultant force and direction motion is with the positive direction. So if it is against, that will be negative. While displacement sign will depend on the coordinate position relative to its zero position. Next, the following are the problem-solving strategy that may help you solving a problem. First, analyze what you have read and if possible, draw a free body diagram to visualize it more, then add labels. Number 2, indicate consistent positive direction to help you with the signs. Number 3, establish givens and the unknown. Make sure the signs and units are consistent. For example, if we're talking about speed, the unit should be meter per second and not meter per second squared. Okay? I always start solving by first FBD kung kaya namang i-drawing, then the givens. Kung sa given pa lang, especially to the unknown, nahihirapan na kang i-identify, you cannot proceed. You should know what you have and what is missing to be able to do the fourth step, which is select the equation or the formula that could help you to find the unknown and the other one. So, as I said kanina, the formula will depend to the given and to the unknown. So, don't be confused between the kinematic variables and their units. Number 5, lastly, substitute the given and do the math in order to solve the problem. We have sample problems here and we will try to solve them. For problem number 1, you are to drive at 300 km to an interview. The interview is at 11:15 a.m. You plan to drive at 100 km per hour. So you leave at 8 o'clock a.m. to allow some extra time. You drive at the speed for the first 100 km. So for the 100 km, your speed is 100 km per hour. But then the construction work forces you to slow to 40 km per hour for 40 km. So what would be the least speed needed for the rest of the trip to arrive in time for the interview? Our given here is the total distance you need to drive from your home to the interview venue is 300 kilometers. So the time of interview is at 11:15 and you leave at 8 o'clock a.m. So, and the speed for the first 100 kilometer is 100 kilometer per hour. The speed for the 40 kilometer is 40 kilometer per hour. Our unknown here is the least speed needed for the rest of the trip to arrive in time for the interview. So how will we solve that? So we need to solve for the speed. So what's the formula for the speed? S is equal to D over T. So in order to solve for the speed, we need to have the total distance. So nag-solve ka pa lang ng speed after we've traveled 100 kilometers and 40 kilometers. So you need to solve for the distance you still need to travel. So how will we solve that? Final distance is equal to the total distance you need to travel, which is 300 kilometer minus 100 kilometer minus 40 kilometers, because you already traveled 140 kilometer. So 300 minus 100 minus 40 is 160 kilometer. So tapos na tayo sa D. So doon naman tayo sa time. So we need to find the time you still have. So hindi siya diretsong ganyan since we need to find the time it took you to travel this 100 kilometers. So, ilang oras yung ginugol mo para sa 100 kilometers na to. So, how will we solve that? So, balik tayo dun sa formula nating S is equal to D over T. So, i-derive natin yung formula. Time naman yung hahanapin natin. So, that will be T is equal to D over S. So, distance over speed. That's why we are doing this. So, the distance is 100 kilometer and your speed at that distance is 100 kilometer, which will yield 1 hour. So, sa 40 kilometer, ang speed mo ay 40 kilometer per hour. So, it took you 1 hour to go with that 40 kilometer. So, dito na tayo ngayon. So, final time is equal to the total time. So, ano yung total time natin? That will be 3.25. Siguro, but 3.25. So, from 8 to 11:15, that will be 8, 9, 10, 11. So, that is 3 hours and 15 minutes. So, but hindi 3.15. Kalito siya, diba? So, 3.25 because 1/4 hour is equal to 15. 60 divided by 4 is equal to 15. So, 1/4 converted into decimal, that will be 0.25. That's why our time is 3.25 and not 3.15. Subtract the hours. 1 hour minus 1 hour. That would be 1.25 hours. So, that's our time left. So, now we can solve the speed na. Let's go back to the formula. S is equal to D over T. Our distance is 160 kilometer. Our time is 1.25 hour. So, the least speed needed for the rest of the trip to arrive in the interview is 128 kilometer per hour. So that will be our final answer. Next, problem number 2. The position of a particle is given by x minus 20t minus 5t cubed, where x is in meter and t is in second. So, yung first, we are looking for letter A. When is the particle's velocity 0? So, our unknown here is time. Letter B, when is the acceleration 0? This is also our unknown here is also time, where acceleration is 0 while in A, velocity is 0. And C and D, for C and D, For what time range? Say positive or negative. So let's solve that problem. So we have our given here x is equal to 20t minus 5t cubed. So for letter A, when is the particle's velocity 0, meaning our v is equal to 0. So going back to the definition of the velocity is equal to the derivative of x over derivative of t. So we need to derive our given basic derivation, that will be v is equal to 20 minus 15t cubed. So squared, I mean. So we will equate the equation by 0 since velocity is equal to 0. So we're going to solve for the t. So transpose 15t squared, that will be is equal to 20. Derive both sides by 15. That will be t squared is equal to 1.333. After that, we will extract square root both sides. That will be 1.15 seconds. That will be the time when the particle velocity becomes 0. Next, at letter B, when is its acceleration 0? So our acceleration here is equal to 0. Just like with letter A, the definition of the acceleration is equal to the difference derivative of v over derivative of t. So we need to derive the v here, which is 20 minus 15t squared. So when derived, that will be negative 30t since the constant will be 0. So a is equal to 0. So 0 is equal to negative 30t. So solving for the t will be 0 seconds. That will be the time that the acceleration will be 0. So for letter C, if the acceleration is less than 0, so our t is positive. So D, if our acceleration is greater than 0, our time would be negative. So problem number 3. You are driving toward traffic signal when it turns yellow. Your speed is the legal speed limit of v sub 0 is equal to 55 km per hour. Your best deceleration rate has a magnitude of a is equal to 5.18 meter per second squared. Your best reaction time to begin braking is t is equal to 0.75 seconds. To avoid having the front of your car enter the intersection after the light turns red, should you brake to a stop or continue to move at 55 km per hour? If the distance to the intersection, the duration of the yellow light are A, 40 meter and 2.8 seconds, and B, 32 meter and 1.8 seconds. So we are talking here whether you're gonna stop or continue with this given. So let's solve. So let us first write our given. Our v sub 0 is equal to 55 km per hour, but we need to convert it into meter per second. That will be 15.28 meter per second. Next, our acceleration is 5.18 meter per second squared. Our time is 0.75 seconds. Our final velocity would be 0 meter per second. So let us now solve for the problem. We need to find first the distance. So x is equal to v sub 0 over t. Maybe you're wondering where did we get that, so we're going to write it in a scalar quantity. That will be d is equal to st, but that's in scalar quantity. And in vector quantity, that will be x minus v sub 0 over t. So our initial speed is 15.28 meter per second multiplied by time 0.75 seconds. So our x would be 11.5 meter. So we also need to solve for the distance with this formula v squared minus v sub 0 squared plus is equal to 2a multiplied by x minus x sub 0. That's in the uniform acceleration motion, if I'm not mistaken. So derive the formula by where x the unknown. Maybe you're wondering, where did x sub 0 go? It is 0, that's why I didn't include it anymore. So substitution, 0 meter per second squared minus 15.28 meter per second squared all over negative 2a. It's negative since we are talking about deceleration. Putting that in our calculator, that will be 22.5 meters. So let us now give our attention to the letter A, 40 meter and 2.8 meters, 2.8 seconds, I mean. Are we gonna continue or break? So to solve that, we need to add the two distance we've solved, which is 11.5 plus 22.5 meters, which is equal to 34 meters. So you can travel at 34 meters. Is it less than 40? If yes, we will continue. So solve for the time. Derive the formula S is equal to d over t. That will be the distance over the speed. So the distance is 40 meters. Our speed is 15.28 meter per second. So our time here would be 2.62 seconds, less than 2.8 seconds, which is true. So we will continue. Letter B. Our given are 32 meter and 1.8 seconds. Are we going to continue or to break? So to solve, we will do that again. 11.5 meter plus 22.5 meter. That will still yield 34 meter. Is 34 less than 32 meter? Of course not. That's why we need to break. So to solve for the time, that will be x over v sub 0 that's 32 meter divided by 15.28 meter per second is equal to 2.09 less than 1.8, which is false. So we also need to break. So next, problem number 4. With what speed must a ball be thrown vertically from the ground level to rise a maximum height of 50 meters? How long will it be in the air? So we have two unknowns here, the speed and the time of the ball in the air. We have first to identify our given, which is only 1, the vertical height denoted by y equals 50 meters. So our solution here, we can use the formula v is equal to the square root of 2gy. We will do substitution after that, and that will be square root of 2 multiplied by 9.81 meter per second squared multiplied by the y, which is 50 meters. So that will be 31.3 meter per second. That will be the speed for the ball to rise at the maximum height. Next, we will solve for the time so that can be seen in the formulas flashed kanina. So deriving the formula, we can V minus the VO minus all over 9.81 meter per second squared. So the time would be 3.19 seconds. But hindi pa tapos yan because that's only the time that the ball reached the maximum height. Paano pag bumaba na? So we need to multiply it by 2. Paangat. Yung pag-angat niya is 3.19 seconds. Yung pagbaba niya din is 3.19 seconds. So that will be 6.38 seconds. That will be the time of the ball. Next, problem number 5. An ion position vector is initially r is equal to 5.0i minus 6.0j plus 2.0k, and after 10 seconds, er is equal to negative 2.01 plus 8.0j minus 2.0k, all in meters. In units vector notation, what is its average velocity during 10 seconds? So we have here the initial and final position of the vector. So let us first write our given. Our initial position vector is r is equal to 5.0i minus 6.0j plus 2.0k. After 10 seconds, the ion position vector is at r is equal to negative 2.0i plus 8.0k j, minus 2.0k. So we're looking for the average. So how will we solve for the average velocity? That will be average velocity is equal to the final minus the initial. So final, we will only write the constant. So that will be negative 2, positive 8, negative 2, minus the initial position, which is 5, negative 6, positive 2, divided by the time, which is 10 seconds. So basic subtraction, we need to first change the sign. Negative 2, 8, negative 2, negative 5, comma, positive 6, comma, negative 2 all over 10 seconds. So, equals negative 7, 8 plus 6 is 14, negative 2 is negative 4 all over 10 seconds. Tapos, pag iiwalayin natin sila, that will be negative 7 over 10 seconds, comma, 14 over 10, comma, negative 4 over 10. So we will do lowest term. Negative 7 over 10 will still be negative 7 over 10. 14 over 10 will be 7 over 5. Negative 4 over 10 will be negative 2 over 5. To write the final answer, we will include the letters, the notations. It will be I plus 7 over 5 J minus 2 over 5 K. That will be our average velocity for the ion.